Hello everyone. So far we've been 5 animations videos in this series. Initially we made delta movements that makes the movement consistent, easing functions that made it feel natural. Lerp made odd move your the objects move follow your cursor, and physics gave ball a real gravity and momentum. But every single one of those was automatic. The ball moved on its own. The cursor followed its own path. You're just watching the screen, that's all. But what if you grab it? Like, that's what inertia is for. You drag an arm that goes across the screen and let go. And it doesn't just stop. It carries the energy from your hand. It slides, it decelerates, it bounces off the walls and slowly comes to rest. Like I do on the screen right now. I am clicking it, dragging it, and moving it, and it will just bounce like this. That feeling, that weight you sense when something resists stopping, that is inertia. And it's the same physics behind every swipe gesture of your phone, every draggable car in a UI, like every scroll within your momentum you ever used. Today we are building it from scratch. Like uh, what we are going to build is click, drag, release, momentum, and deceleration. The wall bounce, everything just using the JavaScript, not without any framework or libraries. So yeah, let's build this one. And welcome to Scratch. And today we are going to see about inertia movements and deceleration logics. Let's start with the coding directly. As always, I have created the HTML structure and the CSS stylings as always. And let's go to the JavaScript. And I have created the variables using identifiers and positional the coordinates and the directional velocities. And the new thing here is dragging equal to false. This Boolean value I created. What this means is I have created this because it acts as a safety gate between two states, whether the ball can follow the cursor or not. So that is why. And I have created previous X and previous Y values too. What this means, it stores the ball's position from the previous frame. As you can understand, as I have shown in the intro, the ball is bouncing and moving in different unpredictable directions. So it will these variables will store that previous values to keep calculations uh, uh, in a good way, in a legit way. So now we'll go straight to the logics here. Now, as I have shown in the intro, the first step is we have to click the ball, and then only we can move the ball. So that operation is mouse down. That is what we are doing exactly. So the mouse down, I'm selecting the orb and giving it an add event listener, and the event is mouse down. Then I'm writing a function, the function, and inside that I'm declaring is dragged as for true. It's dragging as true, and we have to change the orbs style orb style and give it a cursor as grab cursor. That means the cursor will become like give cursor grabbing because the cursor will become like a hand, like a structure, like hand grabbing thing. That is why. And now we have to move the mouse now. To move the mouse, selecting the scene window and giving it an add event listener, and the event is mouse move. Let's try that. I'm writing a function with parameter event listener E and writing the main logic. Here I'm declaring using the if logic. Here is draggable is not true. That means is draggable is not true. We have to stop the execution. So return. So I'm creating another variable called the rect. If the our ball is movable, that is it is draggable. I'm going right. Select the scene and using a new JavaScript method called get bounding client rect. What this does is this calculates the exact live position of the arena container box itself. That means we can store these bounding coordinates so that the global screen space will be localized into the arena space. We can calculate the ball's exact position easily. That's why. Because we are dragging and it is changing dynamically. So that's why. Now we have to declare the previous section, previous y values. Previous x value is x coordinate value and previous y value is y coordinate value. And now I'm going to declare the x and y values. The x e dot client x minus ret of left value subtractor with ops client width divided by 2 because we are going to select the center point. That's what. Similarly, the same for y e dot client width ret dot top here and select ops client height divided by 2. And next, we have to declare the directional velocity step. Select velocity in x direction and calculate it by subtracting the previous x value and the x coordinate value. The velocity y in y direction is y minus previous one. Oh, that's all. Now we have to move the mouse up. That means we have to unclick the ball. So up, mouse up, selecting the window, giving it an add event listener. The event is mouse up. And I'm writing a function here. Here the same, it is the same exact opposite as the mouse down function. That's all. It is simple. This dragging here is false here because we are not moving the ball anymore. So it is false. Giving the off style, and saying the cursor to grab. That's all. Grab means it will just be a like a hand. The cursor will change into a hand like a shape. That's all. Now we have to continue to execute this as an animation loop. Execute the animation loop. I'm writing a function called animate. Inside this, we are going to write another if logic. If not draggable, if it is not draggable, we have to write the x and y coordinates. X should be added with the velocity. That means the direct velocity y direction, x direction, velocity x, and similarly for y, equal velocity y. Now we have to calculate the deceleration. Deceleration is a thing to stop the ball. That means in a real world situation, no floor or no object will have zero friction in reality. It can exist. Those kinds of things can exist in experimental things, but in real life operations, there won't be any such thing that has zero friction. The friction can be low, but it cannot be zero. That is the reality. So, so to decelerate the ball, we are going to control the velocity, directional velocity values. The velocity x, we are going to multiply the current velocity with 0.98. So we are reducing the friction. Sorry, reducing the speed by using friction. Velocity in y direction, the same, multiplied with 0.98. Next, we have to stop the tiny movements. Stop the tiny movements. Why we have to stop this is when calculating, we are calculating it as a decimal. So, and in the next thing, I will also declare negative points too, because when we move the ball, when we move the ball, it will move down, up, and other different directions too. It when there is a small slight negative value too, if there is present a small negative value, the ball's movement will be heavily affected. So to control that, we have to make the negative values as the possible positive values too. So uh, I'm giving using if logic. Okay? I'm using map. I'm using absolute method for the velocity value. Velocity x only if it is less than 0.02. Velocity in x direction as 0. Similarly, for the y direction, with map of maps velocity in y direction is less than 0.0. We have to declare velocity y is equal to 0. Velocity y equal to 0. Now that's all. The main part is missed. Now we have to calculate the max x and the max y values. We have did this already in previous animation videos too. So creating a new variable called max x value and calculate right c not applied with because as it is in the x direction applied with minus balls applied with another variable max y seems applied to height minus balls applied height. So that's all. Now we have to calculate the wall collisions here. This is exactly the same way we did in the previous video too. For one position in the x direction, if x is less than 0, we have to make x is equal to 0 and velocity in the x direction is multiplied with the minus 0.2. As I said, I will use the negative edge. So that's it. Only when we do this, when the ball goes in the opposite direction, the negative and negative will become positive. That's why. Next, if say x is less than the max x value, but max x should be greater than max x. This condition is satisfied. You have to make x is equal to max x value and velocity is the same thing. Velocity in x direction is multiplied with minus 0.8. Now we have to write for the y direction. If y is less than 0, that means the coordinate goes in the negative values. We have to declare y equal to 0. We have to calculate the velocity in y direction multiplied with the minus 0.8. For max x values comparison, we have to same like the max y value. If y is greater than the max x, we have to consider y equal to max y. I have written max x here, max y, max y, and you have to change the velocity in y direction to multiply with 0.08 minus 0.8. That's all. Now, to make the change happen, we have to transform the ball. So, with the style transform and the suitable transform is translate because the ball is going to move in a direction. So, translate x pixels, x pixels and y pixels, and y pixel. Now, we have to make this, all these things happen again and again in a loop. Mhm. Inside the same function, we are going to write the request animation frame function method. Request animation frame, call the function animate, and to make the initial call, call the request animation frame animate. So that's all. Now the whole logic is completed. Now let's go to the browser, reload. There is a small error I think. Let's go to the home. Let's see, let's check again. Let's step up. There is some calculation error, syntax error. That's all. I have left this comma here. That is the problem. So let's go to the browser. I click the reload, and when I'm going to click the mouse, sorry, click the ball, and the grab is happening here, as you can see. And I'm moving the ball. See, I'm moving the ball and releasing it. See, it is bouncing and stopping slowly. And I'm clicking, moving again, and it is bouncing on this topic. So that is how we use do the inertia and other movements too. Inertia and deceleration movement. So this can be used in websites as a like a eye-catching thing. Like in in GitHub, you can see we can drag and place the files. For the same similar things, we can use this to make the page more visually appealing and visually impressive. Uh, so yeah, you can see this in lot more places, like in regular simple websites. You can see this kinds of animations. But in sites like Upwords and similar sites, you can see these kinds of animation, even more complicated animations too. You can see that. So yeah, and another subscriber subscribed yesterday. So thanks to him for subscribing. Now we are 13 subscribers. So please subscribe and leave a comment so I will know what you think about my work and how I can improve myself. Uh, it will really help me a lot. And I have also launched a new Fiverr account, so you can contact me if you want any work, any gigs, anything. I am really open to work. And yeah, that is it for today. And I will meet you guys in the next session. I will leave all the links in my YouTube about page. So yeah, thank you. Have a nice day.